Hey guys, welcome to our channel. It got brought to our attention that some people still aren't getting the things we've been doing lately, and that's understandable. It's pretty new as far as I know. So, we've been trying to come up with answers for the Mandela Effect, or to the Mandela Effect for the Mandela Effect community. All right. Now, we started out by pointing out changes that other people missed or didn't. I don't know about miss, but didn't talk about, put it that way. Then we went hunting ourselves, but pointing out the changes at some point seemed like a moot point because we had a graph or a chart or a model, I should say, that told us that there were going to be infinite changes already because you had infinite outcome points, infinite realities. All right. Quantum physics. If nobody's ever quantum physics, some of you have probably heard about it because you've been looking at the Mandela Effect, and part of the Mandela Effect is, in a lot of people's opinions, quantum physics. In me and my fiance's opinion as well. All right, so you've got part of what you're seeing as changes. They have what's called a quantum computer. All right, now I suppose I should provide links about the quantum computers, but the quantum computers calculate um, complex problems by using or reaching into parallel realities. And a couple years ago, when I was doing this research, at that time they had no less than, they said, 12 quantum computers operating in no less than 7 different realities apiece to solve complex problems. Okay, so right there, and the more you research quantum computers and quantum physics and quantum computing, while they're calculating something, there's a connection open. All right, and all this information is exchanging while the calculation's being made, and when they close the connection, wherever the information is where the information stops. That's where it is. That's where you get song changes, logo changes. Some of them, not all of them, though, but some of them are quantum computers making these calculations. All right. So we decided to start calculating variances on the songs and plotting them into a graph to see what percent they changed by.
I think you should explain how you came up with that formula.
I'm going to.
Okay.
Well, yeah, yeah.
I think it's
So,
important.
well, you know what? I don't really. I came up with the formula because um, I remembered how to calculate variance percentages from, I don't know, it must have been high school math, I suppose, basically. But there's more to it than that because you really do. I'm gonna take Meatloaf, I'd Do Anything for Love as an example. All right. Because what you got, the formula for figuring out a variance percent for this, you need to figure out how many changes you have in your song. All right. And in the case of I'd Do Anything for Love, there's 2 changes. All right. But you need to figure out your changes in the song. You can do that. All right. At least to a certain degree, you can, to what you remember, to what you can catch. Okay. So to that degree, you're going to figure out the changes, or we figure out the changes, and you still don't know the variance percent though, all right? So your change equals your variance percent, and you'd have to take your variance percent times the number of words in the title that could change plus the number of words in the song that could change, and you have to add that up. And your changes, whatever this variance percent is, times this number should equal your changes. All right. So you're going to know your changes though. So you got two changes, and we still don't know our variance percent. All right. So it's going to be your change is going to equal your variance percent times, and in anything for, I'd do anything for love, but I won't do that, is in parentheses. You have 10 words in your title. So your variation percent, you take your variation, your 2 equals your variation percent times 10 words in your title plus 794 words in your song that could change. All right. And then you've got 2 equals your variance percent times 804, which means whatever your variance percent is times 804 is going to equal 2. All right. Now, in order to get this, you must divide your changes by your total number of words that could change, which in this case is 804. So you're going to take 2 and divide that by 804, and then we round to 2 decimal places. You got to move it. You got to move your decimal 2 places over and round to 2 decimal places. And in this case, your variance percent ends up being 0.25%. 0.25%. And then we're plotting that into a chart like this. Wherever it falls, we're plotting it. We got 4 pages of these charts so far, almost 4. We're counting this as a page, even though it's not a page. It's just what we started with. All right. And this page. And if you can tell, I mean, these are consistently making a pattern. Okay. You got a pattern happening with those changes, and that brings us to letter extractions. Our letter extractions, we are simply taking whatever changed. In this case, the word the at 423, take the vow and seal the pact, became take the vow and seal a pact. So the changed to a. All right. And I'm certain of that. I have the album somewhere. I know this song, and the changed to and at 6:38, when I watch you dance and the thunder roll, changed to when I watch you dance and the thunder rolls. And for me, that is 100% change. It won't be for everybody. That's not how the Mandela Effect works. I get it. And not everybody sees the changes, but these are the changes. So in order to extract the letters from that, what we've done, and this is a good example. Well, this is a really good example because you have the, wherever I'm at. Oh yeah, the changed to yeah, the changed to pact. So we took, we took the T, the H, the E, and the A. All right, because nothing cancels out. Now on our roll to rolls, where? Oh, come on. Here it is. So roll to rolls. If we can see this, the R, the O, the L, the L will all cancel itself out, and you're left with S. And we put S, so our extracted letters are THEAS. Now, those seem perfectly random, and we've done that for several songs so far. And what we wanted to do then was see if we could establish a farther pattern. So we started looking for codes within the changes of each song. And we found a farther pattern. If you watch our other videos, our previous videos to this, you'll see that these extracted letters and us decoding them have yielded very similar results. Companies on the stock market, elements, compounds made of element, carbon and uranium element, and uranium thorium compound. Like they're target, we think they're targeting these things, or these things are being calculated, guys. Um, Elements on the periodic table, compounds, companies on the stock market, financial groups, um, medical research, cell research. I mean, we're learning all sorts of stuff. I mean, we didn't know half of this stuff existed, guys. So, what we're getting out of these, and the theory, guys, is that when they make these quantum computer calculations, all right, these quantum computers will make these calculations and exchange these bits of information, and it will inevitably leave a code in its wake of what it was calculating. Right? But that's not limited to these songs. That's going to be in your art changes like the Mona Lisa. We've had art targeted here that we found in these codes. Um, yeah, but these songs are a section of changes, and we can calculate this section of changes, and we can extract the lettering from these changes, and we can decode some of what these quantum computers are calculating, some of what these operators are targeting, right? I don't know that it's necessarily good. Some of it is genes, the TH gene, the EY, EYA gene, and then there was a gene, a protein coding gene that got hit, targeted, or calculated. But basically, we can calculate this section of changes, and believe me, guys, this is a small section of changes. These songs, and even the way we can decode it, guys. I mean, look at one of these longer examples, and we did decode this one frontwards and backwards. But guys, a quantum computer will take these letters and arrange them in every way possible to make any calculation necessary and code it in its wake. Now, as a human being with only so much capacity, I could only get so far doing it. We did it frontwards and backwards, and that is two ways the quantum computer would code it. But it would code it in other layers. In the lettering alone, it would arrange those letters and code it, and code probably multiple targets that we're not even getting, guys. All right. And on top of that, it would probably put numeric values and layer codes inside of codes, because you're dealing with a quantum computer. And if you don't know what a quantum computer is, I will provide some links with this video. So basically, guys, we are trying to calculate a section of these changes. Now, we can't really calculate shifts, like straight across shifts. I don't know what we'd get out of those, but a lot of these are quantum calculations, and there's a pattern You guys, there's a pattern here in all these charts, and this seemingly random extractions are yielding unrandom, patterned, farther patterned results in our opinion. Again, you got and I don't know if am I explaining this okay at
I think
all.
you're doing great.
Um,
I do. But maybe you might want to touch on the difference between a regular shift and the shift of a quantum computer.
well, see, that's a regular shift. It'd be like if me or you died and then we shifted. You know, we wouldn't notice our death, but we'd shift. There,
Other people would perceive it, but we would just keep going, not
yeah,
even
other
realizing
people
it.
would perceive our death and bury us and all sorts of things, and we would just move on, and things would seem a little bit different. That's back in some previous videos. All we can do, guys, is try to calculate what these quantum computers are targeting for now. That's what we're doing.
And we're also hoping that maybe possibly once we put some numerical value to these things, that we might figure out that these things are leaving some type of like, I guess for lack of better wording, an IP address in our in our perception of what an IP address would be on like a laptop or whatever.
Right.
So we will be doing that later on as well.
Yeah, like an IP address, like a signature of what address the quantum computer is running from. Um, it's leaving, and I don't know that there's any way for them to prevent that. When these quantum computers are making these calculations, they are leaving a code in their wake. And let me say again, we're only catching with these songs a small section of these codes. And heck, guys, some of these codes could be skipping songs. How would we know? And how would we know what song the rest of the code skipped to? We wouldn't. But all we can do is what we can do. And I think we're getting a wealth of information from it. I know we're learning a whole lot
Absolutely.
about things we didn't even know about. So, and let me say something else. If it's important enough, if you didn't know about it and you didn't think it was important, join the club. But let me tell you something. If it's important enough for these quantum computers to be targeting, it's important enough for me to learn about.
And also, we got a lot of people looking for answers, you guys, and this is the main reason that we're doing this is we're looking for answers of why these changes are happening and why these things are happening in case we didn't cover that already. The reason why we're doing this is because we got people looking for answers, we're looking for answers, and we're hoping to do the best we can and learn as much as we can because knowledge is power to try to maybe find some answers. We have no idea what we're going to find. But it's definitely brushing us up on a lot of things, and we're finding out a lot more that we didn't know, and we're going to provide you with as much information as we can for those of you looking for answers, and that's what's really important to us and why we're doing this and taking so much time to do so.
Right, and it's not a small amount of work, guys. I mean, it looks that way when we make a 20-minute video, but there's hours that go into decoding these things and then learning a little bit about each thing that we find. A lot of it's stock market. Why not? If you had a quantum computer and some money, why would you? And you would if you had a quantum computer, you'd have money in the stock market. Of course, you'd target certain things to manipulate it. Makes perfect sense, and it's all over these codes.
And
And
if we can ever get our hands on a quantum computer, you better believe we will be using this knowledge to try to trace
figure out,
back this information
trace it
and
back, figure out even
yes,
more, guys.
yes.
We're doing our best now without a quantum computer, and I hope that somebody understands this. Maybe this will help a little bit. We're running over 19 minutes, so I'm going to try to cut it here.
If you guys have any questions or want to know further anything else that we might have missed, let us know.
Yeah, definitely, guys. We're not perfect, and again, we don't have a quantum computer, and as far as we know, we're not quantum computers. So again, there's only so much of this stuff we can actually calculate, but it's a start. It's a start to answers, guys. So at the very least, it's a start. And for now, thanks for all your thumbs up, thumbs down. Thanks for all your comments, subscriptions, feedback, and help. And thanks a lot for watching, guys. We hope this helps. If not, let us know. And for now, you guys have a great rest of your evening.